Have you ever wondered what happens to the oceans when we pump too much carbon dioxide into the atmosphere? When we ignite our engines, power our homes, or even just exhale, we contribute to a change that is slowly but surely altering the face of our blue planet. It's a subtle shift, barely noticeable on a day-to-day basis, but the effects are profound and far-reaching. Intrigued? Well, the answer to that question is a phenomenon called ocean acidification. Ocean acidification is a lesser-known side effect of global warming, but what exactly does this term mean? Simply put, ocean acidification is the ongoing decrease in the pH of the Earth's oceans, caused by their uptake of carbon dioxide from the atmosphere. Let's break it down. You see, about 1/3 of the carbon dioxide that humans release into the atmosphere ends up in the oceans. When carbon dioxide dissolves in seawater, a series of chemical reactions occur. Essentially, carbon dioxide and water combine to form carbonic acid, which is a weak acid. This carbonic acid then breaks down into bicarbonate ions and hydrogen ions. Now here's the kicker. The increase in hydrogen ions from this process leads to a decrease in the pH of the ocean, making it more acidic. Hence the term ocean acidification. But it doesn't stop there. The increase in hydrogen ions also reduces the concentration of carbonate ions. Now, you might be thinking, so what? Well, carbonate ions are incredibly important for marine life, particularly shell-building organisms like oysters, clams, and coral reefs. They use these ions to build their calcium carbonate shells and skeletons. But with fewer carbonate ions in the water, it becomes harder for these creatures to build and maintain their shells, leaving them vulnerable. Moreover, the increasing acidity can also directly harm other marine creatures. For instance, it can affect the behavior and physiological processes of fish, such as their ability to smell, hear, and evade predators. So, as you can see, while ocean acidification might sound like a complex scientific term, its concept is quite straightforward. It's a process set in motion by the excess carbon dioxide humans are pumping into the atmosphere, which the oceans are absorbing, and as a result, they are becoming more acidic. This increase in ocean acidity can have devastating effects on marine life and ecosystems. But as we'll explore in the next scenes, it's not just marine life that's threatened by this phenomenon. The impacts of ocean acidification have far-reaching consequences that affect us all, and it's a challenge that we need to address collectively. The chemistry behind ocean acidification is quite simple. Picture Earth's atmosphere. It's a vast, invisible ocean of air and gases, including carbon dioxide. When we burn fossil fuels like coal, oil, and gas for energy, or cut down and burn forests to create pastures and plantations, we add more carbon dioxide into this atmospheric ocean. Now, imagine the real ocean, the one with waves, fish, and coral reefs. Here's where the chemistry comes into play. About 1/4 of the carbon dioxide we release into the atmosphere is absorbed by the ocean. When carbon dioxide dissolves in seawater, it triggers a chain of chemical reactions. First, the carbon dioxide and water molecules combine to form a weak acid known as carbonic acid. This is the same stuff that gives your carbonated drinks their fizz. However, unlike your fizzy drinks, the ocean isn't contained in a sealed bottle, so the carbonic acid doesn't stay as it is for long. Almost immediately, the carbonic acid breaks down into a hydrogen ion and a bicarbonate ion. The presence of this extra hydrogen ion is what increases the acidity of the ocean. Remember, acidity is measured on the pH scale, where lower numbers mean higher acidity. But the story doesn't end here. In a healthy ocean, there's a balance between the levels of hydrogen ions, bicarbonate ions, and carbonate ions. Corals, shellfish, and some types of plankton need carbonate ions to build their shells and skeletons. The effects of ocean acidification are far-reaching and potentially devastating. This is not just an academic concern or a minor inconvenience. The stakes are high. The ocean's chemistry is changing at an unprecedented rate, faster than at any time in the last 300 million years, and it's having a profound impact on marine life. Let's start with creatures that have shells or skeletons made of calcium carbonate. This group includes a wide range of organisms, from tiny plankton to larger creatures like oysters, clams, sea urchins, and even some species of coral. As the ocean becomes more acidic, it becomes harder for these creatures to build and maintain their shells and skeletons. It's like trying to build a house when the bricks are dissolving. For some, this may lead to weaker shells or slower growth. For others, it could mean death. But the impact of ocean acidification doesn't stop there. Many of these shell-building creatures are a critical part of the food chain. Tiny shelled plankton, for example, are a primary food source for a wide array of marine life. If these plankton struggle, the effects ripple up through the food chain, potentially affecting everything from fish to whales to birds. Moreover, coral reefs, those vibrant, bustling underwater cities, are also at risk. Coral reefs not only provide a home for a quarter of all marine species, but they also protect coastlines from storms and support human economies through tourism and fisheries. As acidity levels rise, corals struggle to build their skeletons, which could lead to more fragile reefs, less biodiversity, and ultimately, reef death. Finally, there's the potential impact on fish. Some research suggests that higher acidity levels can disrupt the sense of smell in fish, affecting their ability to find food, avoid predators, and navigate their world. As the oceans become more acidic, the balance of marine life is upset, potentially leading to the loss of some species. And with them, we may also lose the countless benefits they provide, from food and livelihoods for millions of people to the very air we breathe. The impact of ocean acidification is a global issue, and it's one that we cannot afford to ignore. Ocean acidification doesn't just affect marine life, it has implications for us all. Imagine the domino effect. Ocean acidification disrupts the delicate balance of marine ecosystems, which in turn impacts the millions of people who rely on the ocean for their livelihoods. The fishing industry, for instance, is particularly vulnerable. As acidification threatens the survival of shellfish and other marine species, it also threatens the livelihoods of fishermen and the food security of communities worldwide. But the impact goes further than just our plates. Many coastal communities are safeguarded by coral reefs, nature's very own seawalls. These reefs, however, are also under threat from acidification, which can weaken and even kill them. As a result, coastal communities become more vulnerable to the devastating effects of storms and sea level rise. Let's not forget about the role oceans play in the global economy. They're a hub for transportation, a source of natural resources, and a key player in tourism. The health of our oceans directly impacts these sectors and, by extension, the global economy. Now, it's not all doom and gloom, there are solutions. The most effective way to tackle ocean acidification is by reducing our carbon emissions. This means transitioning to renewable energy sources like wind and solar, and moving away from fossil fuels. In addition to this, we can protect and restore marine ecosystems. Healthy oceans are more resilient to changes in pH levels. This includes preserving existing habitats like coral reefs and mangroves, and restoring those that have been damaged. We can also invest in research and innovation to develop new ways to mitigate the effects of ocean acidification. This could involve everything from breeding more resilient marine species to developing technologies that can absorb excess carbon dioxide from the ocean. By understanding and addressing ocean acidification, we can help protect our oceans and the life they support. And remember, a healthy ocean means a healthy planet, and a healthy planet means a healthy us. Let's not underestimate the power of our actions. Every small change can make a big difference. The threat of ocean acidification is real and urgent. We've explored the science behind it, the troubling impacts, and the potential global repercussions. We've taken a deep dive into the chemistry of our oceans, unraveling how the increased absorption of carbon dioxide is leading to a drop in pH levels, making the water more acidic. This shift in the ocean's delicate balance is impacting marine life, especially those creatures that rely on calcium carbonate for their shells and skeletons. From the smallest plankton to the largest coral reefs, acidification is a silent but deadly threat. But it's not just about the creatures beneath the waves. Ocean acidification has far-reaching consequences for us humans too. It affects the food chain, biodiversity, and even our climate. And yet, there's hope. We've discussed the ways we can help mitigate this crisis. By reducing our carbon footprint, supporting sustainable practices, and advocating for change, we can make a difference. The time for action is now. We urge you to learn more, to share this knowledge, and to take steps in your daily lives to combat this global issue. Remember, every little bit helps. Whether it's choosing public transportation over a private vehicle, reducing energy use at home, or supporting businesses that prioritize sustainability, your choices matter. Together, we can help protect our oceans and the amazing life they support from the threat of acidification.